Morning, beautiful souls, and morning, beautiful humans. Welcome and thank you for being this podcast, Beyond Via Space. I'm your host, Julie. I'd like to introduce myself as Space Miner. With decades experience in terrestrial mining and commodity trading, I have had experience firsthand to witness the commodity boom and its glory. But unfortunately, the darkness and the sadness behind it all as well. I have seen the wars, I have seen the fights around resources because the deep fear we have that they are running out soon. I have seen the real environmental damage mining has caused to our planet, and I have seen the hazard and harmful environment people live and work there have to suffer. So much so until I step into the world of space and space mining. Yes, I was so thrilled to discover there is a solution, and in our lifetime, we could change and correct some of the mistakes we have made along the way. Space can be the answer to all the issues I have just described, and I'm devoting myself to space and helping to make our settlement a reality sooner. That's also why this podcast, Beyond Via Space, is dedicating to space and what impact it will have to our day-to-day life and how it's going to better our planet and what opportunities it will bring ahead. And today, we are going to discuss one of the centerpiece of the puzzle in space mining, and why it's no longer sci-fi and it will happen a lot sooner than what we could ever imagine. Our guest today is one of the leading scientists in the world on this topic. He is a professor of astronomy and planetary science at University of Central Florida. He received a PhD from Brown in 1991 and has served on 4 science missions for NASA. He currently is a director of the CLASS Center for Lunar and Asteroid Surface Science. Let's very welcome Dr. Daniel Britt.
Okay.
Hi. Yes, Dr. Dan Britt. Well, call you Dan. So
Please.
good to have you. Yes.
So good to be here.
Thank you. Thank you for taking your time and having this really very profound discussion about space mining. And before we get into it, actually, I just would love to know that among all the things, how do you actually start with astrophysics and decide to stick with it?
Well, I started with actual geology. I'm in a physics department, but I'm actually a geologist. I didn't start with that. My first 2 college degrees were in economics. I just thought that planetary geology and space mining would be way more interesting. And so that's what I did.
Well, that's quite a bit shift from economic degree to geology. And why would you find that interesting? And that was probably quite an early time. Do you already see that it's a lot to happening in space?
Yeah, I was actually over 30 when I changed. So I had an early midlife crisis and was bored with what I was doing and wanted a major change. And I was lucky enough to be in the right place and have some good people helping me out. But I literally had to go back and start over as a geology undergraduate.
Oh, wow.
And it took me 3 years to get an undergraduate degree, and then I went to graduate school, and I was literally the oldest graduate student at my university.
Wow. So it's never too late to start all over again, yeah? Perfect.
Well, I ran into a few other old graduate students while I was there. I'll have to tell you the story sometime.
Yeah, I would love to hear. And it sounds like it's going to be a really, really fun story. So before we dive in, I think just for better of understanding for the audience, would you actually explain to us what exactly is space mining and where are we going to mine and what are we going to mine?
The reason you do space mining is that it is enormously expensive to move anything off the Earth. And if you want sustainable exploration and sustainable development in space, things like lunar bases or exploring Mars, the only way that that's remotely affordable is if you get the bulk of the materials that you're going to use, things like fuel, things like oxygen, consumables, water. You get those in space and you don't have to pay thousands of dollars per kilo to lift them off the surface of the Earth. And that's the fundamental reason. But if you look at it in history, during the voyages of exploration from the West and also from China, what they did while they were exploring was they established advanced bases wherever they went, because they recognized that you couldn't haul everything you needed, all the food, all the materials from Europe or from China when you were doing the exploring. And so you had to develop some bases to resupply you and do repairs. And that was the first thing that Columbus did when he discovered Hispaniola, was he established a base.
Absolutely. So actually the order is because we won't have settlement there, it just so much more makes sense to have the raw material locally. I think the general consensus is because we are running out a lot of rare minerals, and that's why we have to go there. But I think both way works, right? I mean, yes, indeed. I mean, there's also a lot of reason why we need to go to space. Just even for an option, right? We don't want, if an asteroid potentially hit us and, it's extinguish of the humanity. And yes, we definitely want to hatch our
That's the joke. The dinosaurs are no longer with us because they didn't have a space program.
That's a good one. I like it. So when we say that we're going to mine space, actually, when we think about mining terrestrially, right, it is the first thing people think about. It is extremely dirty, very, very polluted, because you have to dig very, very deep, to get all the rocks come out, and the mineral content is very low. So 98% are actual rocks. You need to crush them, use flotation, concentrate them, and so on and so forth. So how that would be different in the space? Are we going to go through the same process?
Well, it depends on what we're after. I think the early space mining will be mostly looking for consumables and fuel. So you want things like water and oxygen. You can actually get oxygen out of rocks. Most people don't realize that rocks are about between 40 and 50% by weight oxygen. And you can actually extract that oxygen out of the rocks. It takes a lot of energy, but it can be done. And that's one of the technologies that people are developing in order to establish a lunar base. The other issue is that in the lunar polar regions, you probably have ice, because there are some areas that are permanently in shadow and very, very cold. When I say very cold, I'm talking 40 or 50 degrees above absolute zero. Anything that's volatile, like ices, will accumulate there. And you can literally mine that, and it's relatively easy to extract that material. For instance, you just heat it up. With asteroids, some asteroids have minerals that are 15 to 20 weight% water. And it's relatively easy to extract that water out of that material. You just have to find the right asteroid.
So definitely, indifferent from how common people think that we are going there for platinum and gold, but I think eventually that's what we... to start with.
There is platinum and gold.
Yes.
But remember that platinum in an asteroid is going to be concentrated in particular asteroid types, things that are metallic asteroids. And the platinum itself will be finely disseminated. That is, it will be in micron-sized little blebs within a mass of iron. So you can have a ton of iron, and you might have somewhere between 5 and 30 grams of platinum in that ton of iron that you have to separate out. And doing that separation is not trivial.
Mm-hmm. You mean not trivial? It's complicated?
Well, it's complicated. There are platinum refining technologies for Earth, but you don't get platinum on Earth in that form at all. So you have to develop a new separation technology for that environment.
Wow. So I understand that, before we get to the platinum or any rare minerals, we first need to actually mine is water as well as oxygen. And that's like Z number one, right? And I understood that with water, that could be, once you separate oxygen and hydrogen, and that can be the fuel. And that's its center. And I guess it started with lunar, right?
Yeah, we can do that on the lunar poles, as well as on certain types of asteroids. But remember, with asteroids, there are 17 different types of asteroids. And some are basically useless as resources, and some are very valuable as resources. You just have to pick the right ones.
Yeah, I was just thinking that how exactly we're going to determine which asteroid we're going to mine. I mean, is that just based on distance, or we have the telescope, we can actually analyze which ones we are going for based on the...
You can do pretty much all of this via remote sensing, via telescopes or radar. But what you want to do is you want to find small asteroids that are in nearer space, that are not, and there are lots of small asteroids, and there are probably a reasonable number in nearer space. It's just they're hard to find because they're small. And NASA and the various asteroid search programs usually don't care about them because they're too small to hurt people. If you're smaller than like 50 meters in diameter, the asteroid is not going to really make it through the Earth's atmosphere and hurt registered voters.
Got you.
And if you're not going to be a physical threat, NASA doesn't spend much time looking for them. And those are the sorts of asteroids that are prime resource candidates. So it's not that difficult to look for. It just is something that people who want to develop these resources will have to start searching for.
Okay, so it's not the main focus for NASA, but actually for private company, because they're actually quite close. Very likely they contain a lot more minerals, or they contain
useful minerals.
Resource. Okay, that's
one of the things that I should emphasize early on is that the resource geology and resource economics for asteroids and the moon are entirely different than what the mining industry is used to on Earth.
How so?
And, the mining industry is used to looking for things that have interacted with active Earth processes over the last 4.5 billion years. So an ore is an economic concept rather than a physical one, rather than a geologic one. An ore is just something you can make money out of. And if it's sufficiently valuable, almost anything can be an ore. But for the mining industry, ores are usually minerals that have been concentrated by one Earth process or another. And typically it has to do with volcanism, heat flow activity, continental collisions, all of which occur on Earth and no place else. And so almost all the processes that they're used to dealing with and used to mining do not occur on the moon. They don't occur on asteroids. The processes do occur, but they're just different. And you can't apply the same mining parameters and mining techniques in these new environments because they just won't work. A lot of terrestrial mining is heavily dependent upon using gravity to
do separations,
to provide force, to break things up, to move things around. That's one thing you don't have very much of on the moon. You have 1/6 of what you're used to. On asteroids, you essentially have none. You have to do a little rethinking.
No, absolutely. I should just think the process is going to be so different, right? I mean, first, the energy source is going to be different. Terrestrially, we using largely fossil fuel, and that's clearly not going to be the case in space. Actually, Dan, is that possible? You just, somehow give us a kind of like a visual description, like, for example, when we so-called mine the water from the moon, how exactly it's going to look like? Because I understand there's quite a lot of ice covered, on the moon's surface. There's not required much of the digging.
What we have on the surface of the moon is a regolith. So it's dirt. Yeah. And presumably there's ice mixed in with the dirt, but the exact form we still don't know. I think the most likely form is that it's in small pieces that are mixed in with the dirt. And so one of the ways that you can visualize this is that you essentially strip mine off the regolith layer. That regolith is just this broken up dirt layer, and dump it in someplace, dump it in a vat and heat it. Mm-hmm. And the volatiles will come off. But water ice is only one of the volatiles that will come off. There's going to be every other volatile that you can think of that has worked its way there into what we call a cold trap. So things like mercury, methane, hydrogen sulfide, all sorts of things that could be corrosive and toxic. And you'll have to develop some technology to clean up that mix of stuff. All that stuff could be very valuable and useful. You just have to be able to separate it out and use it effectively.
So effectively, we collect these regoliths, and then
regolith, yes.
Then basically we steam them up. So basically, very likely the water will separate from the rest because the different heating point. And then we need to purify this water, basically, if I understand correctly. Okay.
Correct.
Okay. Seems it's order like lunar first, then we get into the asteroid. And I also see there's a lot of push from both US and China to have a lunar station. And they have a target of 2028 and latest by 2030. Do you think that's a realistic target? Do you think it's achievable?
Well, it's achievable, requires a fair degree of investment, which I don't see anybody is doing right now. There is some investment in the technologies that you need, but if you're going to set up bases, you need the machines that can do the extraction, do the exploration, do the purification. And most of those are not developed right now. And I don't see programs, at least in the US, that are very far advanced.
Interesting. I would have thought that with the tension between the US, the West, and China now, actually is pushing both sides, racing ahead. But actually, the progress on the ground is not as fast as what you guys like to see, I guess.
Well, if you want to have a base by 2028 or 2030, you need to have prototypes that you can test on the lunar surface several years before that. It's 2023 right now. Mm-hmm. Development cycles take 3 to 6 years. And what you don't want is untested technology in your first base.
Do you think that there are actually quite a lot of private companies working on that, which potentially
there are some.
Funding?
There are some, and NASA's funding some, but again, I don't think they're funding anywhere near enough if they want to actually have a base that can actually extract local resources.
That's actually okay. So for us to have a base on the lunar, you said that need to be certain kind of equipment. Is that more for the purpose of like mining the water? That's what we are really focusing on, right? And also the shield from the radiation, I guess.
Well, shielding from radiation is not that hard. It just requires that you do some construction, again, with the regolith. And so you need machines that are designed to move a lunar material and pile it up as radiation shields. Mm-hmm. What you need is several meters of regolith over whatever habitat you have in order to shield yourself from solar radiation.
So what are you saying that
radiation.
Actually the technology front is not that, it's achievable, but it's just the investment is still, or the commitment of the investment is still laying a bit behind.
Yeah.
Okay.
What you need is a machine that can move tens or hundreds of tons of material. And right now what we have are machines that can move kilograms of material.
Yeah, the scaling basically. Yeah, I think we probably see some of the prototype, but if there is enough funding to make it a scale and make a difference.
Yeah.
Yeah. And I think before you actually also touch it regarding how the Earth and the asteroid are formed very differently in terms of, I just wondering why would asteroid has so much more minerals that we need than Earth? I mean, is that because the formation different or?
Oh, well, what happens is that you have processes that concentrate different elements. And so, we live on the Earth's crust. The crust is really the lightest portion of the Earth. And so things that are heavy elements, that are metals like iron, and elements that are called hydrophiles, that is, that they have a chemical affinity for iron. Those are mostly in the Earth's core. And the reason you can talk about mining platinum group elements out of asteroids is that the same process occurred in some asteroids. They melted and differentiated. And the hydrophiles, the iron-loving mineral elements ended up in the cores of those asteroids. So they got concentrated there. Just like they got concentrated in the core of the Earth. Now, some of the things like platinum group elements are in the crust. It's just they're depleted relative to the core. Mm-hmm. But in asteroids, you have the chance to actually access the cores of differentiated asteroids. But since you're mining the cores, the rest of the asteroid has been long ago destroyed, ripped off in collisions. And so you're able to access this concentrated form of elements.
So, do I understand that what you're saying that is just the accessibility? That actually maybe there are good amount of minerals on the Earth, just we have been depleting, and it's also in there's a lot talk about deep sea mining. I'm sure under the water there's, under the seabed, there is quite a lot of mineral there as well, but it's propose a different risk if we actually going to mine them. So why the asteroid, in the space, and there is supposed no life species, at least not what we have find out. So the accessibility, the risk and expose are different. I mean, may I understand that's, is that correct?
Yeah, well, I think it's pretty safe to say that we're not going to run into life on asteroids.
Okay.
They're exposed to the space environment. That's kind of harsh. It would be tough. That said, there's lots of minerals and ores on Earth.
Yeah.
And so it'll be a long time before asteroid and lunar materials can compete with stuff back on Earth. The
Correct.
Competitive advantage, as economists like to talk about, is really using these things in space.
Absolutely.
Because it's expensive to drag stuff off the surface of the Earth.